Well, thank those of you for sticking into the bitter end. I promise there will be drinks of the alcoholic and non-alcoholic variety, brought to you by Maui Economic Development Board. But so I'm Joelle Simon-Pietri. I actually expected we would all get printed programs, so I wasn't going to go into biographies, but just a real quick introduction of myself and my distinguished panelists here. I'm local to Hawaii. I'm actually based on Oahu. I have a very small business with an unpronounceable name that matches my last name. I focus on renewable energy investment advice and technical consulting to heavy industrial companies. That includes petroleum companies, and I do have a focus on the aviation sector. And so the panelists I have here are Aaron Robinson from United Airlines. And so United Airlines tends to speak for itself, but some of the interesting things is that he's actually the head of sustainability as well as renewable fuel procurement for the airline, and has a long background with United as well as Northwest and Delta Airlines, and is also a private pilot and has developed an actual flight simulator application with a good bunch of users. And then over on my right is Neville Fernandez, who actually works for a Finnish company based out of Houston, is originally from Malaysia, if I have that right?
Close, Kenya.
Neste, he'll introduce in a little bit, but it's actually a Finnish fuel company. It's actually the largest producer and distributor of renewable diesel in the world. And so what I have here are a couple of significant players in commercial aviation and fuel market here. So the airline with the most flights to and from Hawaii domestically, and then one of the largest renewable diesel producers in the world. So what we're going to do, since we're talking about a topic that has not been introduced at this forum before, is we're actually going to use some slides. So I'm just going to walk through a scene setter here, which is that we've spent this day so far with some very, very deep dives into electricity regulation and electrical industry, and sort of the back and forth between regulators and regulated. What we are going to be doing on this panel is actually pulling out to a much larger point of view, which is Hawaii's position in the world makes it one of the most isolated populated land masses on Earth. It's 2,600 miles to the next closest location in either direction, east or west. And when we look at energy consumption in Hawaii in context, that's important because to get to and from these small little islands in the middle of the Pacific Ocean, the transportation is by and large by air. And this is a significant portion. The amount of visitor arrivals by sea last year, I actually had to just draw that box on there because it actually doesn't register on the chart in terms of mode. Ground transportation, as far as transportation to and from the Hawaiian Islands, just isn't a factor. When it comes to our food and imported commodities, again, by mode, 90% of our food is imported and it comes by sea. 10% comes by air. And then when it comes to the energy sector, like I said, we've spent a lot of time so far today talking about the electricity sector, which changes slightly from year to year. But if you actually take a look at all the consumers of all petroleum products in the state, then what you end up with is that aviation is actually the largest sector in most years, slightly over a third of the energy use in the state, followed by electricity and ground transportation. And then for the hospitality and tourism industry, that other, the 3% in gas, the majority of the gas actually goes to the hospitality industry. It's used for industrial heating and cooking, laundry, hot water heating for the hospitality industry. So from a tourism point of view, the sectors that are actually most critical to the tourism sector are the aviation and the and the other followed by ground transportation for on-the-ground transportation for tourism. So as far as where the jet fuel is used in Hawaii, not surprisingly, the single largest consumer of energy when it comes to commercial aviation is Oahu, with arrivals, or actually departures really, from Honolulu Airport. And Kahului is actually the second largest. And then sort of pulling back out to big picture, one of the things we're going to be talking about on this panel is the International Civil Aviation Organization. So Governor Ige talked earlier about how Hawaii opted into the Paris Climate Accords. The Paris Climate Accords were specifically focused on domestic and terrestrial uses of energy. So it's focused on electricity generation and the carbon intensity of that, as well as ground transportation and domestic air and marine transportation. What is carved out from that is international. So the International Maritime Organization oversees a program to reduce sulfur dioxide as well as carbon dioxide emissions from the international shipping industry. And ICAO has developed this so far voluntary regime, the Carbon Offset and Reduction Scheme for International Aviation, with a program to reduce the carbon intensity of commercial international aviation starting from a 2020 baseline by 2040. And there's basically three mechanisms that commercial aviation will be able to do that. So the green wedge on the slide up here is sustainable aviation fuels. The orange wedge above that is aircraft technology, basically improving efficiency of the actual aircraft themselves. And then the blue wedge above that is air traffic control measures and airport infrastructure inside airport operations. What this curve up is showing is these are the actual projections for commercial aviation fuel demand going out to 2040 if no action is taken. This is actually mirrored almost exactly by actual jet fuel demand in Hawaii. Jet fuel demand in Hawaii has been increasing at this same slope and this same curve. And part of the reason is because, you know, one of the themes of this conference is where are areas where Hawaii is a leader? Well, Hawaii is a leader as a world-class tourism destination, and our tourists arrive by air. So, you know, my panelists aren't necessarily here to talk about the current debate about carrying capacity and how many tourists is too many, but globally, this is the projection by ICAO as far as aviation demand. It's partly a function of economic development. As growing economies grow, you also have more and more demand for transportation. As households develop more disposable income, they have the capacity to do things like tourism, to be able to start traveling for business. And so this is, these projections are based partly on population growth globally as well as economic development. And so as far as the state of Hawaii is concerned, where I see we can actually take some action is in the sustainable alternative fuel sector and in the air traffic management infrastructure segment. There's no aircraft manufacturers resident or operating from Hawaii, and so don't really see at this state level or at this local level ability to impact on that. So we're going to do a little bit of a deep dive right now into the sustainable alternative fuel segment with my panelists. So Aaron will go first from United Airlines, followed by Neville from Neste. And unfortunately, Jeff Tovett from WestJet sent his regrets. There was apparently bad weather in Canada, so he wasn't able to join us. So we'll just have to channel our inner Canadian and talk about everything from a Canadian point of view to the best of our ability. All right, go ahead, Aaron.
Great, thanks, Joelle, very much for the introduction. So, aviation has been always focused on fuel efficiency as first and foremost our method of reducing carbon emissions. And the graphic I've got up here really illustrates why we care about fuel efficiency. So on the left side, we've got the planes we were flying in the 1930s, and then on the right side, 777s that we fly to and from Hawaii every single day today. And what you can see is that obviously the plane goes faster, much faster. It's got a much greater range. That plane wouldn't even be able to make it to Hawaii from the mainland. And then finally, of course, we're able to make all of these airfare tickets much cheaper, and then, of course, much cleaner as a result of just fuel efficiency has enabled all of these things together. About a decade ago, the aviation industry put together a set of 3 goals regarding climate because we recognized that this was a growing problem and one we would have to face up to. And so we were actually one of the first industries to put together these sets of goals, the first of which was simply committing to fuel efficiency improvements over time. And this talks about 1.5% per year. We've actually done better than that. I think it's to the tune of 1.92% a year since then. Second, we committed to not increasing our net emissions after 2020, which is what Joelle mentioned with CORSIA, and I'll dig into it a little more in a moment. And then thirdly, we committed to reducing our industry emissions by half by mid-century. And certainly in sustainability, it's in vogue to talk about 100% goals versus, this seems pretty puny in comparison at 50%, but I'll go into in a little while why decarbonizing aviation is just so incredibly difficult. So why CORSIA? So again, CORSIA, it's the Carbon Offsetting and Reduction Scheme for International Aviation. The offsetting part means the main way to achieve this goal of what we call carbon neutral growth, not increasing those emissions, is through purchasing offsets. But sustainable aviation fuel is another mechanism to get there. Eventually, the expectation is CORSIA is going to extend to this reduction part and help achieve that 50% reduction. So the map you see up here is looking at all of the different carbon regimes, regulation regimes in the world. There's a whole bunch of them. Some of them are even subnational. And from an airline's perspective, we fly to 65 countries worldwide. We don't want to have 65 different regulatory regimes we work with. We want to have a single one. And so that's what CORSIA, set up by our UN agency, ICAO, set out to do, to ensure that there is a level playing field and a consistent application of regulations as well globally. More notably, ICAO is responsible for things like safety regulations, and that's what ensures that all of the standards, whether you're in an airport here or in Kenya where Neville is from, all of these airports are built the same way, and a pilot can fly into one and another and know what to expect. So, Joelle mentioned, that CORSIA is again an international regime. So in blue on this map, you can see here's the routes, the notable routes from Hawaii, where CORSIA is going to enter into effect in 21. And in red are the ones that are not going to be in that case. So obviously, flights to the mainland U.S., that's a domestic flight. That would be covered if the U.S. were to re-enter the Paris Agreement. There would presumably be some sort of domestic regime set up for that. So certainly the main cases from the Hawaiian context would be Japan, Australia, Canada, New Zealand. Also worth noting on here, you'll notice that flights to China are not included in that, and that's because for the first 6 years through 2026, CORSIA has a voluntary regime by country. And then from 27 onward, it becomes mandatory for the majority of countries, and at that point, China would enter into it. The other thing worth noting is that you can either reduce your emissions by choosing to offset or by choosing to buy sustainable aviation jet fuel. And to achieve that, what CORSIA does is it offers an incentive to be buying sustainable fuels. Right now, it's a small incentive. Let's call it maybe 10 cents a gallon. But we're expecting this equivalency from the price of jet fuel to be going up quite a bit over time, and therefore the incentive to be using sustainable fuels as well. So why not electric aircraft? Is often a question that gets posed to me. certainly it's something of great interest to us, Ampere on the last panel, and we definitely have high hopes for electric aircraft in the future, but it's worth noting two important things. First of all, the technology, the energy density is just not there yet. Today, if you wanted to have an electric airliner, it would actually have to be maybe 15 times bigger to host all the batteries from it. Great example is Solar Impulse 2, which flew through Hawaii several years ago on a round-the-world flight. It had a wingspan of a 747. It carried 2 people, and it flew at 45 miles an hour. So we're really hopeful about these technologies, but they're going to take a while to scale up. And photo here is Oahu. The aircraft also had to stop here for 9 months for repairs. Beyond that, the other piece that's worth noting is we're buying aircraft technologies today. The airplanes we have in order today, they're going to be in service for another 25 plus years. And so we need a solution that works for those as well, not just waiting for electric aviation and hopefully solar aviation at some point to become a reality. So what are airlines doing in this space? At United, we actually have 2 sustainable fuel partners. The first is a company called World Energy, based in Los Angeles. And they're producing sustainable fuel for us, delivering it to LAX. And this fuel is made for us from waste products, from used cooking oil and other products like food processed material that's unused in food production. And it's delivering a 60% reduction in what we call life cycle emissions. And so today, that fuel's going into our flights at Los Angeles International Airport. And so the 10 flights coming here to Hawaii today are powered in part by this sustainable fuel blend. Second phase we're working on, we actually have an equity ownership stake in a company called Fulcrum Bioenergy, and they're actually taking this a step farther. They're looking at landfill waste, and that's going to have an even greater CO2 reduction. And that's going to be coming online in a couple of years for us and producing fuel as well. Just a look at kind of the industry outlook in this space. So you can see on here some of the airline logos that are involved in it. There's a lot of commitments out there in the space, but the challenge is that this is still a very relatively small amount of fuel compared to what we really need as an industry. So if this set of airplanes on this slide is all of aviation industry fuel demand in a given year, then this is the total commitments you saw on the prior slide. And it's worth keeping in mind that those total commitments go out many years, not just 1 year. And this is only looking at if all of those commitments were to happen in a single year. So we know we have a great big challenge, and it's going to take a lot of time and investment by the industry to achieve these goals. Just looking at a couple of the airlines in particular, California has really been the center of the sustainable aviation fuel universe the last several years. And in part, it's because California has really set up the right incentives, the policy incentives for it. So the state has actually set up financial incentives and credits. So if you deliver that fuel into California to an airline there, you'll get a substantial credit. It's right now on the order of $200 a metric ton of CO2 to be delivering that sustainable fuel. And so it used to be, 10 years ago when I entered this space, we had these very small reductions in CO2, 10 to 20% was kind of the norm. The big question then was, how do we certify this? Is this fuel safe? How do we get there? We've advanced since then, and really today the big question is, where are we going to find the money to scale up? And certainly that's where stable policies are really critical. So to wrap up, I think there's a lot of potential here in Hawaii. One of the important things to remember is that there is a price differential between where sustainable aviation fuel is today and where conventional is today. In Hawaii, that gap is certainly quite a bit smaller since the conventional prices are generally quite a bit higher. But we do think sustainable aviation is coming a lot faster than we think. So if we look on the ground transportation side, it took about 100 years to go from, 110 years, to go from kind of the first cars to a hybrid car. Took another 10 years to make it to the electric space. And actually on aviation, it's kind of been a similar pace. It's been 110 years from our first flight till we've got sustainable fuels going every single day. And we're hopeful that we'll get to sustainable aviation, truly sustainable aviation in the near future. Thank you. On to Neville.
Aloha, everyone. Thank you, thank you. That's the last time you're going to say that today. I'm the last speaker here. So thanks very much. So my name's Neville Fernandez, and I'm from Neste. Just a show of hands, who before today had heard of Neste? Hands up. Okay, thanks, David. You're even sitting in the front row. Thank you. So not very many people. So let me tell you a little bit about Neste, and then I'll talk about renewable jet fuel and how we plan to decarbonize aviation, and then turn it back to Joel for questions and answers. So Neste is a Finnish-owned company. We're headquartered in Helsinki. We are actually traded on the Helsinki Stock Exchange. So a brief safe harbor statement that all the information I give you today is given in good faith. Of course, there's regulatory risk, there's market risk. So please don't use anything I say today to make investment decisions in Neste. We are both a petroleum refining company and a renewable refining company. We started about 70 years ago. We have 2 petroleum refineries, total capacity of about 260,000 barrels. So just to put that in perspective, the 2 refineries in Hawaii have a total capacity of about 130,000 barrels a day, so about twice the size. And then 10 years ago, or just over 10 years ago, we started our renewable fuel refinery, total capacity now of 65,000 barrels a day, spread amongst 4 refineries. And again, to put that in perspective, although it's half the size of Hawaii's 2 refineries, we're by far the largest renewable diesel player in the world. And renewable diesel is different from biodiesel, and you heard Bob King talk about biodiesel. We do use the same feedstock, so waste oils and greases, but instead of adding methanol and producing biodiesel, that Pacific Biodiesel does, for example, we put that through a refinery process, and we make hydrocarbons or renewable diesel. So as mentioned, we're the world's largest producer of renewable diesel. We have 5 refineries, or 4 refineries right now, and we just announced a 5th refinery. So our 2 refineries located in Finland, a 3rd one in Rotterdam, the Netherlands, and our 4th one in Singapore. And we just recently announced our 5th refinery will also be located in Singapore. Total capacity of about 1 billion gallons per year. And by 2022, when the 5th refinery comes online, we'll have approximately just under 1.4 billion gallons per year. We've recently reorganized our company. We've split what was traditionally our oil products business and our renewable products business. We've taken that and we've now formed 3 more divisions in our renewable diesel business. And we split our renewable products business into renewable diesel, renewable jet fuel, and renewable plastics and chemicals. And what I'd like to talk about now for the next few minutes is our focus on decarbonizing aviation and our renewable jet fuel. So as Aaron and Joel mentioned, there is a big need to decarbonize aviation. Aviation accounts for about 2% of greenhouse gas emissions, and if it were a country, it would be the 7th largest emitter of greenhouse gases after China, the USA, India, Russia, Japan, and Germany, and then would be aviation if it were a country. And the industry continues to grow approximately 5% per year, and that means if you look at the airplanes in the sky today, there'll be twice that many in just 20 years' time. So there's a big need to grow sustainably, to continue to grow, but to keep the greenhouse gas emissions and other turbine emissions in check. And Aaron and Joel described that some of the industry initiatives which are happening. So there's been a lot of success. Aaron talked about the improvements in fuel efficiency. There's a lot of work being done by airports to reduce their own carbon footprint. Airplanes are getting lighter, as we saw from Aaron's good example. Jet engines are becoming more efficient. But still, with all these improvements, we still need to have a renewable jet fuel because for at least the next generation of planes, we will need a liquid fuel to power that aircraft. And so renewable jet fuel must be part of that solution because petroleum jet fuel is really the cause of these greenhouse gases and turbine emissions. So there are 5 approved renewable jet fuel technologies which have been approved today. You can make renewable jet fuel by gasifying municipal solid waste and producing a jet fuel out of that. As Aaron mentioned, their investment in Fulcrum, that is what Fulcrum is going to do. You can gasify woody biomass and produce renewable jet fuel. You can hydrotreat waste oils and greases. That is what Neste is doing. That is what World Energy is doing, that is currently supplying United Airlines at LAX. You can make renewable jet fuel out of sugar. That is a technology that is being commercialized now by a company called Amaris. And you can even make renewable jet fuel out of ethanol and butanol coming from sugars and starches and then processing it further to hydrocarbons. So there are technologies, they have been been made available since 2009. Besides being a low carbon fuel, and I'll show you some of the comparatives between renewable fuels and other forms of energy, renewable jet fuel is also a superior jet fuel. It has a higher energy density than petroleum jet fuel when measured by mass. The implications for this is that you can load less fuel onto a plane and have the same amount of energy, meaning you can take more passengers, you can extend your routes, you can take more cargo, a lot of advantages for the airline. Renewable jet fuel, by the way, let me apologize here. I've used this acronym called SAF, Renewable Jet Fuel RJF, also known as Sustainable Aviation Fuel, SAF, or as Aaron put in his slides, Sustainable Alternative Jet Fuel, SAJF. They're all really the same thing, different acronyms. Renewable jet fuel has also a higher thermal stability, leading to, again, big advantages for less carbon formation in nozzles, in turbines, potentially lowering the cost for airlines. And finally, renewable jet fuel not only is a low carbon fuel, but it is also a clean burning fuel, similar to renewable diesel, lowering tailpipe or lowering turbine emissions. So when you use this at airports, not only are you contributing to mitigating climate change and lowering greenhouse gases, but also contributing to a better local environment around which the airports are located. So Honolulu Airport, for example, which Joel showed, burns about 500 million gallons of renewable jet fuel. Well, that jet fuel, if part of that could be renewable jet fuel, part of that air quality could also be improved around the airport. So let me, a couple of last slides here. We talked a lot about electricity today, and so I wanted to show this slide to compare what is the carbon intensity of renewable fuels compared to petroleum fuels and compared to electricity. So this first slide here shows the alternative transportation fuel carbon intensities per megajoule of energy. And you can see Hawaii is relatively high, and these figures are from the Argonne National Lab and the California GREET model. And when I looked at this, it seemed pretty high compared to what I was hearing this morning. And I noted that this was based in 2015 when Hawaii used about 80% fuel oil to produce electricity, and I understood today that it's now down to about 70%. So this carbon intensity will also be reduced, but still, when you look at this on a per mile basis, you'll see that renewable fuels still have, and these are Neste's renewable diesel numbers issued by the California Air Resources Board. You can see that renewable fuels still have a very, very large role to play to decarbonize our society, both on the ground transportation and also on the renewable jet side. So the renewable jet numbers, which I haven't put here, will be similar to our renewable diesel carbon intensity numbers, slightly higher to account for extra processing and some transportation. But you can see the potential of renewable jet fuel and renewable fuels in general to help decarbonize the economy. So as Aaron mentioned and as Joel mentioned, there have been great strides to introduce renewable jet fuel into our economy. And as we now continue to grow, the policy, for example, Aaron mentioned the low carbon fuel standard policy, and the involvement of other stakeholders will be needed to really make a push for renewable jet fuel and to make it available on a continuous, widespread basis. So let me conclude then. I'll turn the mic back to Joel, and I'll just the main points I wanted to, some take-home points for you. Aviation continues to grow, and it must grow as other economies are catching up to the Western economies, and people want to fly more. They want their goods faster to them. So aviation will no doubt continue to grow. And those companies that can lead the growth in sustainable aviation will be the ones who have the first mover advantage. Renewable jet fuel has to be part of that solution, despite all the other good efforts that are being done in the industry. And what we will need then is stakeholder involvement and enabling supportive policies. So let me end there. Joel, and I'll turn it back to you. Thank you very much for your attention.
So for both Aaron and Neville, talk a little bit about policy mechanisms that could be applicable here. You know, as we look at trying to set conditions for success for sustainable air tourism in Hawaii. What are some good and bad examples from other regimes that you could perhaps give us some insight into today?
So maybe I'll start with the bad examples and turn it over to Neville for the good. Certainly, we've seen instances elsewhere where the solution that governments have decided is to dampen demand. So if you come from the UK and fly to the US, you're paying something in the order of $120 to $200 as their air passenger duty. And the intent of that is to essentially act as an excise tax on the fuel. The trouble with that tax is that it dampens demand, which obviously as an airline we don't like. But more importantly, from the sustainability perspective, none of that revenue is going to actually solving the problem. Instead, it's just going to the British government, British Her Majesty's Treasury, and where we would love for it to go, and we would certainly be less concerned about it, is if it's going into things like research and development for more sustainable fuels or more efficient aircraft technology, and actually working towards solving the problem instead of just trying to tax an industry that's also vital to economies.
Thank you.
Let me talk about the most recent policy initiatives that have been put in place to incentivize renewable jet fuel, and that comes from the West Coast. So starting this year, California became really the first state to incentivize renewable jet fuel by allowing renewable jet fuel to generate carbon credits under its low carbon fuel standard. And they did it as an opt-in, meaning that renewable jet fuel doesn't have to reduce its carbon footprint, so refiners and importers and airlines don't have to include renewable jet fuel in their fuel mix. But if there is renewable jet fuel introduced into the state, then it can generate carbon credits. And so that is actually a win-win because it allows for more supply of carbon credits, reducing the price. And as Aaron mentioned, carbon credits today in California are trading at about $200 per metric ton. And with the carbon intensities of the fuels that I showed there, it translates to equivalent of about $1.30 per gallon as an incentive for renewable fuels. So it provides a good incentive without at the same time incurring a large obligation for refiners and blenders to lower their carbon footprint. And this model has been followed now in Oregon, which has adopted the same opt-in method. In Washington State, they're considering a bill, House Bill 1110, the Clean Fuel Program, which will also follow this opt-in for renewable jet fuel. So I think those are some of the good policies that could be adopted, and maybe Hawaii could also consider that. What we've seen is that where those policies are put in place are suddenly a big driver to incentivize companies to not only put in production for renewable jet fuel or for renewable fuels in general, but to direct it to that particular location.
So if we were to sort of encapsulate that, an example, of a tax on fuel that simply goes to government actions and doesn't actually incentivize any industry investment, ends up being suboptimal in your experience. And a policy regime that actually allows for sort of tradable incentives among private parties is more successful, and also helps to actually monetize some of the otherwise intangible benefits of sustainability. Let's talk a little bit about sustainability, because we've thrown out these different terms, but I'm sure there are good and bad examples of things to do, to try and get to renewables. So how do you or how does the industry measure sustainability of the supply chain for a renewable jet fuel?
Yeah, certainly. So there's lots of definitions of sustainability out there from lots of different parties, certainly. And so actually at ICAO, that's one of the topics being debated right now, is what does that mean and what does that look like? From the airline perspective, ultimately we're going to, of course, be bound by these regulations, but certainly the biggest thing that comes to mind when people think about this is the food versus fuel debate. So 10 years ago, when airlines started testing out sustainable fuels, they were coming from sources like the first flight was on babassu nuts. And so the pundits went out and figured out how many thousands of nuts were used for that first flight, and then how many billions or trillions, whatever it might be, would be needed to power the entire global aviation fleet. And of course, we don't see any situation where there's a single solution that's going to solve the problem. Instead, we're looking really at region-specific solutions. But one that's wasn't contemplated 10 years ago and is really taken to the forefront is this idea of moving away from growing crops and instead switching to waste feedstocks as our solution. Now, there's been talk certainly. Is waste as a feedstock, is that sustainable? And so that takes it another level. But in the meantime, we're looking at is we're solving a problem for the world, and we can debate the sustainability of waste certainly once we've solved that problem.
Maybe one thing I can add, thanks Aaron, one thing I can add to that is when you try to quantify sustainability, and Aaron mentioned there are many different definitions or wide definitions, but one way to try and quantify that is to look at the carbon intensity of the fuels. And in that carbon intensity calculations, they include not only the actual direct emissions of the fuel and it's burned in the turbine, but all the carbon emissions throughout the life cycle. So for renewable fuels, it's if you're getting the feedstock from virgin oils, then how much energy goes into clearing the land, planting the crop, fertilizing it, applying water to it, cutting it, harvesting it, crushing the seed, gathering the oil, transporting it to the refinery, making the renewable fuel, and transporting it to the market. So all of that is calculated. In addition, they also look at what are the unintended consequences. So if land was cleared to plant that crop, and that land was already being used, was already sequestering carbon. And of course, these are big issues where you have the tropical rainforests in South America and in Southeast Asia. If that land had been cleared to plant these energy crops, what is the negative impact of that carbon then being released when you clear that land? So all of these are considered in the carbon intensity calculations and so considered in the sustainability of the crop. And in addition to that, besides the carbon intensity, then what is the water usage? What is the labor usage? Is there any inequities in that? And when renewable jet fuel or renewable fuel producers look at their feedstock, and Neste certainly is one of them, were voted the third most sustainable company in the world in 2018. We look at all of these aspects, and this is all listed on our website. We have a very transparent website and accounting for these, but many other companies do that as well, and driven partly by regulation, driven partly by customer demands, and then also driven by our own mission and our own goals to not only produce renewable, low carbon fuels, but sustainable fuels as well.
So I've got a couple questions from the audience, and so the first one is for Aaron, but Neville, if you've got anything to add. It asks, why is United so far ahead of the other airlines? Why has United been so much more active in that slide that you showed? Is it a social goal, competitive advantage, or preparation for future legislation?
I mean, I think realistically it's all of the above. All of those things are certainly important to us as we look at the airline. Part of it is also protecting the business and the future of the business. So 11 years ago, I was working in fuel efficiency, and that was the year that oil prices spiked. And at United, we actually grounded 100 airplanes that year. And it was the single largest grounding of airline industry capacity in the industry's history, not related to a bankruptcy. And so, that was certainly a very scarring experience. And so anything we can do to protect against those oil price spikes is highly valuable. The other thing I would point to, though, is just, I think innovation has really been part of United's DNA ever since the start. So it's going from things like being the first airline to have flight attendants, to safety innovations, like crew resource management, or more recently, things like electronic ticketing, mobile apps on your phone, elements like that we were all really the first airline to lead the space in. I think those are, certainly taking the lead and trying to be first to market rather than being, say, a fast follower or a laggard. It's just part of who we are as a company.
And so for Neville, from talking about Nestle's point of view, what is the interest of the company in being, such a leader in, especially, planting a flag as far as green diesel?
Yeah, so we were a petroleum refiner for 50 years. And in 2007, when we developed this technology and patented this technology, we actually separated. Neste was part of the Fortum group, the power group of Finland. And we demerged from Fortum to form Neste Oil at the time to start this technology. And we were driven by the fact that as a refiner, as a petroleum refiner, we had to decarbonize our products. And the way we sought to do it is that we had to develop a fungible fuel which could be dropped in the petroleum infrastructure market, but had a lower carbon footprint. So that's really what drove us to develop these solutions for renewable fuels. And as we take now the next step, we will make renewable plastics. And we've also announced an initiative late last year that we will take petroleum plastics and through a process of plastic liquefaction, we'll feed that into our petroleum refineries. So the hierarchy of recycling plastic, you reuse the plastic, and then you mechanically recycle it and repurpose it for another use. And whatever can't be reused or recycled mechanically, you then take and landfill it or incinerate it. Well, that's the plastic we're after. And we're going to liquefy that and put it into our petroleum refineries. But to go back to your question, Joel, it's because we see the need, and it's even faster than we thought it would be back in 2007, the need to decarbonize fuels and the need to decarbonize transportation, because we know that part won't shrink, it'll increase.
I think as a sort of a convener of conversations about commercial alternative aviation fuel, one thing I would add, for that question that was asked of you, Aaron, which is why United would take such a big position, is out there in the audience, please raise your hand if you flew at any time in the past 2 years on Aloha Airlines. Yeah. So, or ATA. And so those are airlines that went out of business from one day to the next because of fuel price volatility and being upside down on their fuel budgets. That year, where United actually started to, survived and was able to start working, but also acquired Continental and doubled in size, nearly. But that was, there was an actual real existential crisis for the industry. And so sustainable aviation jet fuel has not just sustainability impetus behind it, but also pricing ones. So why don't you talk a little bit about what the industry goals are as far as actual fuel prices? So.
Yeah, so since Neville's here, I'm going to say that the price, our goals on price for sustainable fuel is it's got to be the same price. And actually Neville sometimes introduces me as United Airlines, Aaron from United Airlines, we're his best customer who never buys anything. But if he were to cover his ears, then I would say the fuel price volatility is really the main driver that we look at, and anything we can do to really shift that and focus and have a different volatility, maybe it's hopefully a lesser volatility and a different one too, then that has value to us as a company. And so those are things that enable us and make us willing to pay a premium for sustainable fuel beyond just the environmental and social benefits that it offers.
Thank you. I'm afraid we are out of time, but I'm glad we were able to get to at least a couple of these great questions from the audience, so thank you for sending some in. And feel free to catch Neville and Aaron. It's very late their time, but catch them at the break. Thank you.
Thank you.